We've been hard at work on Dragonfly, and I'm happy to provide a brief update on all the work we've been doing. Of course, over the past several months, the priority has been team health and safety. So this picture from the team meeting last year looks rather different with our new perspective with COVID-19. But fortunately, we've been able to continue a lot of the design and development work as well as our reviews remotely. And we've worked strategies for safe in-person activities like testing, and of course are tracking the impacts due to COVID on aspects of the schedule. The next slide shows the Dragonfly science goals. We use Titan as a natural laboratory to study prebiotic chemistry and put that in the context of the Titan environment, the Titan methane cycle, the organic cycle, and liquid reservoirs, both water and methane, as well as searching for potential biosignatures. So there haven't been changes to our science goals and objectives, and we've been working with NASA to refine the specifics of the L1 requirements for the program level requirements appendix. To achieve this science, the next slide shows the different elements of Dragonfly. Of course, Dragonfly is a rotorcraft lander as shown on the right. And this allows us to perform measurements both on the surface and in flight as we travel from place to place to explore different environments on Titan. The other elements of Dragonfly are the cruise stage at the far left, and then the entry vehicle, which is next to it. And a lot of the ongoing work that we've been doing is updates to the designs of these elements, defining and refining the interfaces between them, etc. The timeline on the next slide shows the trajectory. We've been working on a high fidelity trajectory following NASA's direction to use our backup launch date in 2026. So following this trajectory, we arrive at Titan in 2034. And we do a direct atmospheric entry. So that's shown on the right. The atmospheric entry at Titan is very different from Mars, where we have a much thinner atmosphere. So at Titan, this is about a 2-hour event from the entry interface at the top of the atmosphere, descending down through the atmosphere to Titan's surface. And so a lot of the work that's been going on, again, is refining the entry vehicle as well as the engineering science instrumentation that will be taking measurements during the descent of the entry vehicle. The next slide shows the timeline on Titan. We land on the right. You can see the landing ellipse amid Titan's equatorial dunes, just south of the 80-kilometer diameter self-impact crater. Dragonfly will explore Titan for about 3 years. This is 74 Titan days, each of which is about 16 days long. So 74 Titan days of operations, during which we'll be able to traverse up to 180 kilometers to explore both the dunes and interdunes, and then get into the impact crater, the deposits associated with the impact crater, where organic material may have had the opportunity to mix with liquid water at the surface of Titan. During this traverse, we'll explore a couple of dozen unique landing sites throughout the process. So another area of active work has been refining this concept of operations, the information for each of the instruments, and defining the mission science operations center and supportive operations, especially activities like that require the ground in the loop. So this slide shows the mobility, some of the work that's being done on the mobility subsystem. This, of course, is required to support Titan exploration, and this illustrates our leapfrog exploration strategy. The abbreviation BC is breadcrumb, and this just shows how we, when we take off from one landing site to go to our previously scouted landing site, we'll actually fly past that to our a planned area of interest and scout out a potential future landing site. And then we'll come back and land at the previously scouted landing site. And so this shows how the mobility system builds up the information about the tracking and navigation along the ground track. Nominally, we'll actually, if you stay on that slide, nominally we'll perform one flight per 2 Titan days. So this is actually about 1 flight per Earth month. Most of the time is spent on the surface, making science measurements, communicating with Earth, et cetera. Okay, so the next slide shows the payload. This is designed to perform the multidisciplinary science measurements to achieve the science objectives at each landing site. And so this is the kind of ghosted view of the lander with the different instruments color-coded. We have a geophysics and meteorology package shown in yellow. This is the Dragnet package. It has meteorology sensors as well as a seismometer contributed by JAXA. The orange and red are the mass spectrometer drams and the drill system and pneumatic transfer system, Draco, that breaks up material on the surface and brings it into the mass spectrometer for measurement. And of course, this is the mass spectrometer is from Goddard with contribution from Kness, and Honeybee Robotics is building our the drilling system. DragonCam is in blue here. There's a suite of 8 science cameras as well as 2 navigation cameras being built by Mail Space Science Systems. And then finally in purple, there's the gamma ray neutron spectrometer that's being built here at APL. So again, this is an area where there's a lot of really active development in the instruments, the environmental testing, interface definitions, and definitions of requirements, as well as the requirements flow down from the high-level science requirements down to the instrument level 4s and level 5s. The next slide shows a lot of the recent activities that we've been doing. We've completed, well, of course, as I said earlier, the priority is team safety. And so most people are continuing to work remotely with in-person activities like testing being conducted as possible. This is certainly a challenge that everyone is facing at this time, and we're working to make sure everything can be performed, and any work that needs to be done in person can be performed safely. We've completed our subsystem and instrument peer reviews this spring and summer in advance of our internal system requirements review just earlier this month, which we passed. We have all the documentation as well that's associated with this step in the mission. And I mentioned the ConOps refinements. The eye chart at the right is a graphic showing the SciBox tool that we use to track activities and resources. In this case, it's showing the battery state of charge. We also use this tool to track data downlink as we're playing data back to Earth after during the Earth contacts. The next slide shows some additional recent activities. A lot of the work, as I mentioned, it revolves around the design and interface refinements and development of the cruise stage, the entry vehicle, the lander subsystems, and payload. We've also been working on the high fidelity trajectory simulation and the engineering science investigation. The images at the right show some work that's been done in terms of some wind tunnel testing and computational fluid dynamics analyses that are ongoing. And we've also had the opportunity with the Mars 2020 MMRTG to actually make some in situ measurements related to the thermal plume and the atmospheric ionization from that MMRTG. And there's an upcoming paper that'll be coming out soon about the results from those measurements. And then, of course, there are a lot of programmatic activities, defining the institutional interfaces, the international agreements, coordinating our planetary protection plan. So there are a lot of things ongoing that we've happily been able to continue during this period when people are working primarily remotely. So the last slide talks about some of the upcoming activities. Of course, following our system requirements review, the development activities continue. And the next milestones become the subsystem and instrument PDRs as we come up on the mission PDR scheduled for November 2021. In the near term, we have selections underway For the first cohort of the Dragonfly Student Guest Investigator Program, there will be 3 students selected for this cohort who will work with Dragonfly from this year for a couple years through 2022. We're also going to be participating in a trial program that NASA is doing to allow guests to observe team meetings. And so we're looking forward to that for our next team meeting coming up this fall. And then, of course, in this new virtual world, everything, including conferences and OPEG, is being done remotely. And so I included some links to some recent videos about different aspects of Dragonfly. And of course, we'll be making presentations at upcoming conferences this fall. So we're on track and making good progress despite the limitations in work environment right now. We've got the Dragonfly preliminary design moving along, completing the design trades we need to complete, executing testing, defining environmental specifications, and maturing the system in advance of our PDR in 2021. Thank you.